Hey everybody, welcome back to Young Engineers of Today. I hope you had a good weekend. I hope you've had some good time off, a fun snow day, something like that. Hope you had some time to enjoy the snow. And I hope you're ready to continue with more Scratch. Now, this Scratch presentation goes on for a good bit longer than what we'll actually be doing, and that's mostly because a fair amount of this stuff is not necessarily applicable towards what we're planning on doing. So I'm going to jump around a little bit. Things might get a little bit faster paced in order to give you guys some more experience with the programming side of things so that you get more comfortable with it. Obviously, if at any point you want me to go over anything again, feel free. I'm going to try and keep it at, at a reasonable clip, though. I'm not going to go absolutely insane with all of the new material. I just want to make sure that we cover a lot of the basics that are directly related to control flow and programming and things like that, which you will be utilizing. Not so much, costume changes and backdrop changes and a lot of the stuff that exists in Scratch, because that's not going to be necessarily applicable. So with that in mind, let's go ahead and continue with Scratch. So scratch.mit.edu as before. And it's probably going to be a pretty safe assumption that you guys will already have like your login queued up and everything like that. I'll give everybody a minute to let that load, and then we'll go ahead and we're going to create a new project this time, because whereas before I just sort of showed you the general sort of idea behind Scratch, we'll actually get started on a Pong game in order to understand some more concepts behind programming in Scratch. All right, so I'm going to go ahead and click Create here, and I'm going to get a new blank project. Now, before we get too much further, let's see here. We'll do a little bit of review. So what do these numbers represent down here, the X and the Y? You can go ahead and just throw your answer into the question box. Yeah, exactly. Coordinates. Close. Not the position of the sprite unless we put our cursor there, because it is in fact the position of our cursor. But I like that. You have the exact it is a position. So yeah, where your mouse is. Exactly. So that's that's what the coordinates resemble or represent, excuse me. How about the one thing we need in order for a program to run whenever we click the green flag? Yeah, this command, when the green flag is clicked command. Anytime that's clicked, or anytime that's added to something, it will, thank you, Victor. It will start that block of code whenever the green flag is clicked. So yeah, exactly. How does Scratch determine what order to run things in? Like, what order does it run commands in? Yeah, by the order of the attached blocks, by the order that you put it, the way they are connected. Yeah, essentially. just the order that we determine, but essentially from top to bottom. It starts at the top and runs down to the bottom with no variance unless we tell it otherwise, which is sort of a confusing qualifier to put on that, but it'll make more sense in a minute. So, like I said, we're going to make a Pong game, and the point of this Pong game is to teach us a little bit about responding to input, affecting output, a little bit about loops and things like that, and we'll sort of make diversions into other programming concepts that might be useful to know in order for you to work with the Raspberry Pi. With that in mind, this cat doesn't make much sense for our Pong. We're actually not going to use it entirely, so I'm just going to go ahead and get rid of it. If I right-click on it, I get the option to delete it, so I'm going to go ahead and select that. Boom, cat's gone. Now, here's another important point about Scratch. If I had code connected to that cat, oh yeah, and you can also click on it down here. That's true too. If I had code connected to that cat, like if I had my walk right and say hello code from last time, and then I deleted that cat, that code is gone forever. The code that we create in Scratch is tied to basically things that exist in the Scratch program. So they could be sprites, they could be the backdrop, but they have to be attached to something in order to run. They can't just be sort of exist independently of anything. And that's mostly because there's a whole bunch of, there's a whole language built around it, but regardless, it's a bit more like a scripting language in that sense, as opposed to an actual programming language. But, well, it is a scripting language, but regardless, it's good to use it in order to learn how a programming language might flow. At any rate, we're going to go ahead and add a couple of sprites that we're going to use for the Pong game. So what I'm going to do is I'm actually going to show you guys what I clicked on. I'm going to click on the little sprite icon here next to new sprite. It's a little picture of a troll or something like that. You mouse over it, it says choose new sprite from library. I'm going to go ahead and click on that one. And as you can see, it brings up a whole bunch of different stuff. We've got Abby, we've got Airplane, we've got Amon, Anina Hip Hop, blah, blah, blah. A whole bunch of different sprites. Some of them are vector art, some of them are pictures, some of them look like they might be, maybe there's some pixel art here, who knows, but chances are they're mostly going to be vector art or straight up pictures. What we're interested in, though, are a couple of specific sprites. So what I'm going to do first is I'm going to scroll down to about T, and I'm going to find Trampoline. Here it is. Boom. I'm going to hit OK. And now we brought the trampoline in. I want to put the trampoline at the bottom because the trampoline is going to be our paddle for Pong. And I'm going to add one more sprite. And I'm going to use let's use just the plain old ball. Boom. So now we've got a trampoline and a ball. And it's also important to note that when you place these items into the world, they tend to be placed right at about 0, 0. If I can actually find it. There we go. And you might go, well, that's really weird. It's the upper left corner which is placed at 0, 0, and that's just another sort of strangeness about programming and things like that that has to do with the fact that just like computer screens generally are, pictures their 0, 0 tends to be in the upper left-hand side. Like most computer screens, their 0, 0 is up here in the upper left-hand side. And then Y increases as it goes downwards and X increases as it goes to the right. That is the same thing with a lot of pictures as well, so that they follow the same convention. Scratch is a little strange in the sense that it places 0, 0 in the exact middle of the screen. However, sprites still keep computer convention, and so 0, 0 is going to be in the upper left hand of the sprites. Weird? I agree. Also, my voice didn't really actually make much noise at that point. But that's just sort of, it's a compromise of the accessibility of having, you know, the coordinate system and start in the center versus making it follow conventions that make sense for computer programmers so that they don't have to do all kinds of extra math and stuff like that. Moving the sprite is very easy. All you have to do is just click and drag the sprite. So that's nice, at least. So, first things first. What we're going to do is we're going to make it so that the well, actually, the trampoline's going to be our paddle for Pong, and it's going to be a single-player Pong. Think of it like a brick breaker kind of a thing, as opposed to actual like Pong. Like we're not going to have bricks like Brick Breaker, nor are we going to have an opposing trampoline trying to mess up our day. So yes, well, that would normally be a good suggestion to duplicate the trampoline. We're actually going to skip on that for now because this is going to be Pong Solitaire. It's like playing ping pong against a wall, which is unfortunate, but at the same time, this is going to be much more accessible to code. So, first things first is let's establish the movement for the ball. Now, making the cat move, what category was that under? Does anybody or everybody remember? Yeah, exactly. It was under motion. I saw a couple of votes for events and stuff like that too. Yeah, it ended up being under motion. So it's a simple command, just move 10 steps. What we're actually going to do is we're going to make it move 15 steps. So it's going to move a little bit further. And then, just like before, we'll add our when green flag clicked and attach that so that whenever the green flag is clicked, the ball will move 15 steps. So let me go ahead and click the green flag. So now when we click the green flag, the ball moves. However, the ball does not continue to move, which isn't exactly the idea. It's not like you have to, you know, whenever you're playing, I guess, Pong with your friends or Mario Kart or something like that, you don't have to keep pressing the start button in order to make everything move forward a little bit each time. We would like to have continual motion of the ball. So like whenever you click the green flag once, the ball continues to move so that it's as if, you know, yeah, like it's sort of like a physics thing. Basically so that there's actual motion and there's challenge to the game so that you have to actually stop the ball from hitting the bottom. Exactly. You've got it exactly right. Enter loops. Um, Loops are a way in programming to repeat blocks of code over and 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 over again. I mean, on the one hand, you could always copy and paste a bit of code as many times as you need the code to run. So let's say you wanted to have a bit of code that printed out hello to the screen. You could copy paste those commands that cause it to print hello to the screen so that it 5 times, so that it prints out 5 times. Yeah, we'll get to that point, Victor. No worries. But essentially, yeah. Well, not exactly that, but it's a similar thing. It's not going to be it's not going to be an if statement. But anyway, I'm getting ahead of myself. We could copy and paste that code so it appears 5 times. So it would run 5 times. However, there are easier ways to do it. What if we wanted to print hello 100 times, 1,000 times, maybe even 1,000,000 times? What if we wanted to do something more complex? Excellent question. Yes, it can, and we'll get there. But yeah, it totally can. What if we wanted to do something more complex than just printing something to the screen? Well, having to copy paste that code or retype it 100,000 times would get exceedingly old. So we can utilize the power of loops in order to take a particular block of code and repeat it. Yeah, exactly. And repeat it a controlled number of times. So you could say, oh, we'll do this, 300 times before moving on to the next thing, or we'll do this 5 times before moving on to the next thing, or we'll do this 15,000 times before moving on to the next thing. Or we could do this X number of times, where X is determined at some other point in the program. So like if a person, you can have a program that asks you a number between 1 and 10, and then they type in a number, and then the program will print hello that many times. So that's something you can do with loops as well. They could type 1, and it'll print hello once, and the program will end. They could run it again, and then they could type 7, and it will print it 7 times. And using the power of loops, that would be possible. Now, there's also the potential for a loop to never end. And there are many examples of intentional, infinite loops. That's what these are called, as you guys understand that already. But there are also times when it's not intentional. So it's something that you want to be careful of. Yeah, but okay. How many of you have experience with like Java? Show of hands. How about Python? Okay. How many of you had programming experience in general? You can also raise your hand when you do that too. Are you not able to raise your hand? That should be easier than typing that into the question box. There should be a little hand symbol on your GoToWebinar screen. Oh, gotcha. Okay, so a fair number of you, not everybody, but a fair number of you. All right. So you guys are doing some review then. All right. I apologize. I should have asked that beforehand. Fair enough. Let's adjust a little bit. Okay, so you guys already know how loops work. So in that case, we can stick this inside of a forever loop in order to ensure that it continually moves in that direction. Because obviously this is the thing that's going to be repeated every time it loops. So if I click the green flag, boom, it goes flying off to the side. Yeah, for sure, no problem. So in that sense, all we have to do is click the flag once, and now we got movement on the ball. On the other hand, we kind of want the ball to move maybe in a direction other than just, like, we don't necessarily want to just go to the right every time we click that, because yes, because A, it doesn't ever hit the trampoline, and B, it would be good to have some kind of variance in our program. So in that sense, what we can do is we can include this turn command, which will cause the ball to turn in a random direction. Well, once we establish it to be a random direction before it gets started. So real quick, where would I place this command if I wanted to establish the direction of the ball before moving it around? Before what? Well, okay, so like here, and decreasing the y by 5 could work, but this will actually introduce more variance in its direction. Plus, it requires fewer commands. So that's certainly an idea. It would also mean that there wouldn't really be any sort of there's an inbuilt randomness to what we're about to do, as opposed to that, which is sort of more of a hard-coded motion of the ball. Yeah, exactly. It spins round and round, right? That doesn't exactly seem ideal. What about this? What if we put it outside of the loop? And the ball's running away. Let's bring the ball back. There we go. So now, oh Lord. Oh, duplicate. We'll delete the original ball. So now it goes in a given direction whenever it starts out, and then it heads in that direction. See, we've already got a diagonal direction built into it. Yes. You guys are coming out with great ideas, and I'm glad that you guys are thinking about this. Let me just get through this part, though. If you already know how to answer that question, though, I encourage you to try and puzzle it out so that you can get it to work. Don't stop telling me these things, and also, don't lose track of what we're doing. But yeah, if you've got an idea for how to do something with one of these, I would also encourage you to try out, because a lot of coding is experimentation as well. Whereas I might be telling you how to do these sorts of things. If you've got an idea that ends up working, then fantastic. If you're where was I going with that? If you're not sure, then stick around and I'll go over at least my solution for getting this to run. But you certainly by no means restricted to this. Okay, so in this case, the ball's always turning in the same direction. May not look like it, but as you can see, it's doing a slow turn every time I click the green flag, because every time it turns 15 degrees. Now granted, it also moves 15, which is 15 steps, which is why it's doing this big lazy circle, but it's always going to turn 15 degrees. It's always going to turn 15 degrees. So let's make that a little bit more interesting. We're going to pick a random direction. As you can see, pick random, 1 to 10. In this case, I'm going to make it 0 to, let's actually make it 15 to 45. No, Yeah, sure. Let's see what this looks like. That's not too bad. So what it's going to do here is it's going to turn in a random direction from 15 to 45 degrees. So this way, anytime when we start out, anytime we start the program out, it's going to head off in a different direction every time. We're also going to have an if statement. If statements are, as you guys are already pretty familiar with, a good way to change the flow of the program depending upon the conditions that the program is in. Booleans are an example of a variable that can hold true or false values, which can be used in if statements. But these are generally referred to as control structures or control flow. But yeah, like Booleans are true-false statements. And there are certainly in like Java and C family and many languages, in fact, there are Boolean variables. There are variables of type Boolean, which hold either a true or a false value, and nothing in between, or anything else. They can only hold true or false, and that's because they are simply 1 bit large, and they hold either a 1 or a 0. Well, modern operating systems, it's a little bit different, but older operating systems, yeah, definitely. See, in that case, what that would actually do is just that would actually just make it move up that amount and then stop. But what we want it to do is we want it to change direction and continue moving forwards like it always does. So we're going to do things a little bit differently here. But first, we're actually going to make sure that it stays within the confines of the screen. So what we're going to do is we're going to say if, let's see here. We've got this, under sensing, we've got this if touching edge. So we're asking right now if it's touching the edge of the screen. And if we mouse over it, all right, let's duplicate that so it's back in the center. It should be telling us whether, stop running. Lord. It should be telling us whether or not it's true or false. Regardless, anyway, if it's touching the edge of the screen, then do a thing. So what we're going to do is we are going to oh, there's already one hard built into Scratch. If on edge bounce. Super easy. And boom, just like that, now the ball bounces anytime it hits one of the edges. Now let's do the one for the trampoline, because that one is going to be more interesting interaction. But this is, yep, that's super easy. So we'll go over to sensing, and instead of touching mouse pointer or edge, we'll say if touching trampoline. Then yeah, that was my fault. I just keep getting texts from my other job asking me to come into work, and I can't. Regardless, there was a flip X direction. Apologize, that put me a bit out of sorts. What we could do is we could do the point and direction, except we could point in a random direction just like we were doing before. So we can change this from, let's see here, I believe 0 is directly to the right, and it's got a 360-degree rotation. So let's try. In direction, we'll end it at 359. Let's do 350. And instead of 90, we can do 100. So pick random 100 to 350. So if it ends up hitting the trampoline, it will flip out. Okay, that's not ideal. Man, that thing was, yeah. Okay, that bounced off okay. That did not. So we need to figure out what exactly is going on here. In this case, it's probably better to constrain it to like 145 to 275. Let's try that. Yeah, exactly. Get in there. I feel unstoppable. Ball, probably. Well, okay. We can say... Yeah, it does get stuck under the trampoline sometimes, but it's not, even when it hits the top, sometimes it doesn't register it immediately, or I can't tell if it doesn't register it immediately or it points in a direction that is not useful. What we can do is we can make it right. But again, I don't know if that's because it's not registering the trampoline immediately or if the directions that I have here are not good directions. Let's try, instead of that, let's try this. Let's see what directions we get. Okay, this seems to be like traditional. This is just going everywhere. All right, let's try 1, 2, 2. Hmm. I have an even better idea. Rather than doing this, whoops, I should not have gotten rid of that. Well, when all else fails, there is no undo command. Ah, here we go. Undelete. Undo command is your friend. Let's make this easier. We can actually flip it so that it is Flipping the direction, well, that used to exist. Okay, fine, don't cooperate with me. Okay, let's just reset everything. Point in direction 0, up. And then we'll duplicate this line. So that it will fly off in a random direction when hitting the trampoline. And instead we'll say negative 45 to 45. So now the ball bounces in either direction, and it's actually a very natural looking movement, even though it's an entirely random number. It looks like it's hitting weird, little grooves on the trampoline and stuff like that, and being launched every which way. But regardless, it looks more like how a ball would bounce on something that's an uneven surface. So there we go. All it took was me, for some reason, having issues with that, because that's always fun. Now we have a ball that bounces off of all of the walls around everything and also the trampoline itself. Of course, this is not much of a game because we can't move the trampoline, and also we cannot lose. Probably two things that we should add into this in order to make it an actual game. So that's what we're going to do. Now I'm going to click on the trampoline and I'm going to add some code to it. Yeah, exactly. You got it. It needs to be in a forever loop, though, otherwise it will only, do it a little bit. So set X to, and then under sensing, we can set X to mouse X. And also under events, we'll have it start whenever the flag is clicked. So now the Y position of the trampoline will stay the same. That is its vertical position. However, its horizontal position will move to line up with the mouse cursor. Perfect. So far, so good, right? All right. So far we have the makings of a game. However, we need to have some sort of losing condition down here, right? Well, why don't we just go ahead and we can just paint a nice and easy sprite. It's going to be a rectangular one. It's going to have you could do that too. All right, so let's see here. Undo. We're going to make this impossible to miss, though. And in fact, we're going to have a little bit of a modification to it as well. So we'll add that sprite to it. I'll actually make this costume a little bit larger. Make it take up the whole entire bottom. Done. So now, if I move this down here, and I move the trampoline in front, now we've got a nice red area, nice red area underneath that can denote a very clear game over area. Now let's do something here. Let's go ahead and click on the sprites. Let's see here. We'll add another when green flag is clicked, put it in control in a forever loop, and then an if. In fact, we don't even need this stuff. We should be able to boop. If touching ball 3, then we'll go ahead and we'll broadcast a message. New message name is you lose. Now if it hits it, nothing's going to happen. All right, so this might have to, there we go. Aha. I know exactly what I'm doing wrong here. Do you know what I'm doing wrong here? Well, there's that, yes, but beyond that, does anybody know about broadcasting in this sense? This is the code for Sprite 1. So we want to check if Sprite 1 is touching ball 3. But I like the fact that you're thinking about that. That was a good idea. Yeah, it's made simpler by the fact that Scratch doesn't actually list itself when it's checking for other things that it's touching. So since this is in Sprite 1, Sprite 1 is not listed as one of the available options. In ball 3 is not listed as one of the available options. But yeah, that was thinking outside the box. I like that. How about this when I receive block? What does this look like? Well, it has a bit of a shape that resembles that flag, right? The one green flag clicked. And also, it only has a bottom connection and not a top one. The plot thickens. Also, I can attach things to it independent of this. Let's just do this as a test. So let me go ahead and let it hit the bottom. And it doesn't want to cooperate. Why don't you want to cooperate? Let's change this to, we'll put this in here. There we go. Now you see how the ball's saying hello whenever, as soon as it touches that bottom part. Boop. Now if we stop the script and look at this, it says when I receive, you lose. If I click on the sprite, it says broadcast, you lose. This is, well, this is as close to a function call as Scratch gets. And this is a means for sprites to communicate with one another in Scratch. This is also a means for you to have different bits of code talk to one another and send different things. Rather than using, like maybe a whole bunch of different if statements or something like that, you can use very specific broadcast statements in order to send the proper message to another part of your code. But what this does, this broadcasting bit, is it calls an entirely separate block of code or script in any other sprite that's listening for that. So in this case, this one's listening for you lose. The trampoline, we could have that one listening for it as well. And we could have each of them fire off their own code as soon as sprite 1 sends that message. So now we've got the sprites communicating with one another. In addition, we can set x to 0. We can have the ball say, you lose, good night. And we can stop all. Nice, excellent. So that way, if we hit start, we can bounce it, we can bounce it, we can bounce it, boom. Aha. So let's try this. And then we'll stop all. And now it looks like the ball is setting. We could actually instead update this to be something that makes a little bit more sense. x0, y0. So now it resets each time. Goes right back to the middle. The trampoline is still, we still have full control over the trampoline until it says you lose good night. But boom, and then everything gets stopped. Now, if we were so inclined, we could increase the speed of the ball each time it touches the trampoline by, instead of just saying 15 steps, we could create a variable called speed. We could set speed to 15 in the beginning. All I did to reset it was just have the ball move to x0, y0 whenever you get the you lose message and make everything stop. And that's it. In fact, set speed to 15. And then we can move speed steps, and we can either change speed by 1, or we can set speed to speed. Wait. Oh, good Lord. There we go. Speed plus 5. And for that, the ball will now go faster every time it touches trampoline. In fact, it gets fast really super quickly. So now we actually have a pretty difficult game. Yep, it's as fast as your mouse is. Exactly. Okay, okay. Could I, if I remember correctly. Okay, so show of hands here. Who has a Raspberry Pi or has something that they can use in lieu of it for the subsequent lessons? Or something they can use, for, yeah. I mean, you don't need it tonight. I'm talking about for Wednesday. But for as far as Wednesday is concerned, who could be ready to do a lesson with a Raspberry Pi on Wednesday? Okay, a few hands. Now, who would need some more time before they would be able to work with it, or do not plan on getting a Raspberry Pi before the competition? Yeah. Okay, a couple of hands. All right, well, let me share. There's a program called Fritzing for those of you who either do not have it or are not planning on getting one. Because Fritzing does have a Raspberry Pi or the ability to add Raspberry Pi to the list of parts that exist on it. Let's see here, Raspberry Pi. I know I've used this in the... Yeah. So the one problem with Fritzing is you won't be able to code a Raspberry Pi in it. Yeah, let me share the link with you guys. One problem with Fritzing is you won't be able to code a Raspberry Pi in it. However, you will be able to use it to wire up diagrams. So you can wire things up in order to at least emulate the wiring side of things, and then you can mess around in Scratch and sort of get a feel for how the coding side of things will work. They won't communicate with one another, unfortunately. So it's an imperfect solution. It's what I'm going to have to use in order to show you guys what exactly is going on. Just because I can't do a web camera thing, unfortunately. But regardless, that's what we can use as a stopgap, um, at least in the meantime. I would recommend it, although I know Mr. Dybbuk was talking about having breadboards. I would email him about that, and also the best place to maybe get one in case he doesn't have any more available, because I know he was saying that it comes with a bunch of extra stuff, but regardless, like if you get one online, but regardless, you should be able to at least get one to borrow from him. With that, though, I think I'm actually going to go ahead and do the poll questions, and then we'll leave it open for question and answer time. I apologize for being a bit scatterbrained at the end there. Um, just like I said, work. Uh, Again, I would email Mr. Dybbuk that. He mentioned it the first day, but I would email him that question, and he'll be able to provide you with a link and all of that good stuff, and then he'll actually be able to place that on the website as well, um, the FAQs part, so that people could utilize that information as well. But yeah, so I do apologize for being out of sorts today. Um, we'll go ahead and try and get started with the Raspberry Pi on Wednesday, and then from there we should start making some good progress. So, you know, hopefully you guys are looking forward to that.